Hello and welcome back to section 9.2. In this video we'll be using composite bodies to try to find the centroid of the figure here for example 2. So we're only going to find it in the y direction because it is symmetric. It being symmetric, we know that the centroid in the x direction is along the line of symmetry here. So we only need to find it in the y direction. Y is measured from the ground going up. So there's two basic strategies for this. So remember, composite bodies works by breaking this up into simple geometric shapes, circles, rectangles, and triangles. So one option is we can take this thing, we can break it up into its three pieces like this. I then go and set up a table for segment 1, segment 2, and segment 3. And I find their centers of their centroids in the y direction and their areas. And I do the sum of y times area over sum of area. Instead, what I'm going to do requires one less segment. So we're going to take a box. This box will be 400 wide. And it'll be the total width, this 200 plus this 50. So it'll be 250 tall. We're going to find the centroid of that box. And then we are going to subtract this inner box here. So we'll subtract this other box. This other box is 300 wide and 200 tall. So we can do composite bodies with negative areas, or negative lengths, or negative volumes, and get the same answer either way. The advantage of doing this is that I only have 2 segments to deal with, whereas this one I have 3, so we can simplify the problem slightly. It does create a challenge though with this negative sign, so we do have to be careful there. So let's go look at that. Alright, so we've redrawn the problem here, and I've updated the dimensions to be a little more user-friendly. So my strategy is I am going to take, and it's good if you draw this out, so we're going to have segment 1 minus segment 2. Segment 1 is 400 by 250. Segment 2 is 300 by 200. So we want to find y bar. Y bar will be equal to, for this problem, the sum of the centroid in the y direction for each of these times their respective areas over the total area. Now, if this was a mass or a volume problem, we could also use, just so you have these equations, we could also use that y bar is equal to the sum of the y tilde mass over total mass, or sum of times volume, or over the sum of the volume. And then finally we could do it for weight, where we would say the sum of that for the piece of weight over the sum of the weight. Typically you're going to be working with volumes and areas though, and we're not really going to have masses or weights. The assumption being that we have the same material throughout, so there's no reason to do mass or weight because it'll lie wherever the volume or the area is. Alright, so let's set up a table. So we want to find y bar, so we need to find we will have segment. Let me move this up for you. And that's probably good enough. We'll have y bar, we'll have the area, and then we will calculate y bar area over here. So segment 1 and segment 2. So for segment 1, its y bar is 250 over 2. So just half of that, so it's 125. For segment 2, it is at 100. The area of shape 1, hopefully you know the area of a rectangle, it is 250 times 400. Those are in millimeters, but again, as long as I use the same units on top and on bottom, everything will cancel itself out. We'll be fine. The area for this one is 200 times 300. Now there's a special thing we have to do here. This area is being subtracted, so we need to make sure that we make this area negative. Alright, so let's total that up. So I'll just make another column. So we have the formula for A, the total for A. So you can kind of do it this way. You're trying to bookkeep and keep stuff in line. So get that for you, and I'll put the numbers up in a second. So we end up with 100,000 and negative 60,000. Same thing. Now we're going to calculate y bar A. So we're going to take the midpoint, so 125, multiply it by this to get that. We'll take this 100, multiply it by this to get this one. Alright, so you end up with negative 6 E6 and 125 E5, or 12.5 E6 if you want to make them both e to the 6. Now we total these up. So we total up the area, we total up the y bar, so the weighted area, and then the area. So this becomes 40,000, and this becomes 6.5 E6. And then all we'll have to do is we come back up here to our equation, and we just plug in our numbers. So our total, so this is our summation, this is our summation. So on the bottom, the denominator is 40 E3, 40,000. The numerator is 6.5 E6. And then you just put that in a calculator, and you will get 162.5. And the units on this are millimeters, because you have millimeters, millimeter squared, millimeter squared. So millimeter squared will cancel, and you'll be left with whatever unit you put this in as. So 162.5 millimeters. Can I come back to our picture? Let's just make sure that makes some sense. We don't expect it to be any higher than 250. We expect it to kind of be close to the middle, which is about 125. A little bit higher because I have all this area up here, so it makes some sense. It's above the halfway point, and it's not all the way up. So it seems like it's in a good region. Alright, so again, we did that by taking a large area and subtracting a smaller area. You could have, again, done the same thing by going segment 1, segment 2, segment 3. You would have had 3 segments down here. Same thing, you'd find each one of their midpoints in the y direction, each of those areas, add them up, get their weighted areas, and then do your math. So same exact process. It's just you have an extra line. Alright, hopefully that helps. If you need anything, feel free to reach out.